Hello, welcome to lesson number 7 in our 4th unit, Acute Angle Trigonometry, in our grade 11 University College math class. So today's kind of a summary day and a day to look back at the journey we've taken in trigonometry with respect to the tools that we've developed for different types of triangles. It's also a day just to refamiliarize ourselves with some of the formulas and look at questions where, again, and this is the flaw in the conventional way of teaching, where, like, if I do a lesson on sine law, you can be pretty sure we're going to be doing a lot of sine law in that lesson. But decontextualized, if I just throw a triangle at you on a unit test, you won't necessarily know which of the tools we have at our disposal to use without a little bit of practice anyway. So that's what we're going to do today. So this starts with you just rewriting the sine law and the cosine law. So I'm going to zoom in on that. And I've written out the sine law and the cosine law in particular. I've written just both versions of it. Now, it's not important to memorize all, the dozen versions that are here. It's really important to know the A version of the cosine law. I typically, memorize this guy down here. Sine law is pretty straightforward. So what I'd like you to do is just hit pause here, do some practice rewriting of this into your notes. Again, just as a way of getting it into your head and becoming more familiar with it. So hit pause, and when you're done, come on back and I'll talk you through what's happening at the bottom of this first page. Okay, you're back. Let's get a look down here. Now, normally this is something that I would do in class where I would have you partner up or get into groups of 3 or 4 and just talk about, so number 2 reads, describe the conditions that guide when it is appropriate to use sine law, cosine law, sum of interior angles, primary trig ratios, and Pythagorean theorem. And I usually model the first one for them. So the first one there reads, the sine law can be used with any triangle. So that means any triangle, right angle triangle, non-right angle triangle, it doesn't matter. You can use it with any of them. We use it when we are given a side angle pair and one other piece of information. So that's a summary of when you can use it and how it can be used. So you can use it to find sides or angles depending, and you use it when you have a side angle pair and one other piece of information. So we would do this in groups, and then we would talk about it and we would put it up there. Unfortunately, we don't have a class at the moment. We're just kind of sitting around, so I'm just going to put them all up on the screen right there. This would be a great spot to just sort of pause, copy it down, read it over, make sure it makes sense. This is just an opportunity to review the material, dig back into some of the stuff we did a little while ago, like primary trig ratios and the Pythagorean theorem. So hit pause, copy it down, think about it. When you're feeling good about, having read it over, come on back and we'll look at the exercise for the day. Okay, you're back. You've got this copied, you looked it over. What we did there was to, will help us today as we look through what we're, the triangles that we've been given. So number 3 in this lesson, and this is really the activity, is decide whether the unknown in each defending triangle can be determined using the sine law, cosine law, SOHCAHTOA, that'd be primary trig ratios, sum of interior angles, Pythagorean theorem, or, this is a new category, insufficient evidence. And that would just mean that you don't have enough information in the triangle to actually find the piece of information that's been asked of you. So it says complete the chart to discover the general conditions that guide the use of each. So that sounds a little bit confusing. I'm going to model one here for you at least, and then we'll work through a few more maybe. So it's referring to triangle ABC, PQR, DEF. These are all on the next page of your notes. So if you haven't downloaded the note yet, at the very least call it up on your screen so you can see the triangle that we're talking about here. So the first triangle we're talking about is right here. And it's asking us to find, so what you want to locate is the variable that doesn't have a number on it, and that in this case would be side little b. And I believe it also says it in the question up above. So again, if we're talking about this triangle ABC, this would be the slot here for triangle ABC. It's asking us to find side little b. And the first thing that it asks us is to write down the 3 pieces of information that we've been given. So let's go back to that triangle and get a gander at it. And there's going to be a lot of jumping around today, and I apologize for that. It's not really laid out for this kind of video format. So what have we been given in triangle ABC? So, well, we've been given a few things. We've been given angle B is going to be 62 degrees, and angle C is going to be 35 degrees. So I'm going to go back up into the note, and I'm going to write those down. I'm going to change up my color scheme first. So angle B, 62. Angle B equals 62 degrees. Angle C equals 35 degrees. So I've got those two pieces of information that I've been given, and let's see what else we were given in this triangle down here. We also have been given side little c, if I'm using my labeling correctly, and that would be 30. So let's get that in there as well. So side little c, oh, that's a highlighter. Side little c is equal to 30. So now the next piece says, state the law required and the formula using the correct letters. So let's just jump back to the triangle for a moment and have a look at it. So here's our triangle. We're looking to find side little b. What would the method be here? So again, I'm going to model sort of the thinking I've been trying to model all along, which is, first off, what kind of triangle is this? Is this a right angle triangle or a non-right angle triangle? Obviously, it's not a right angle triangle, so we can't use Pythagorean theorem and we can't use primary trig ratios here. We have other tools in our disposal. We have sum of interior angles, sine law, and cosine law. So the first thing I usually look for is have we been given a side angle pair? And in this case, we have been given a side angle pair. We've got this angle and the side across from it. So if we have a side angle pair and one other piece of information, we can go get side little b. So side angle pair, that means the sine law. So jumping back up here, I'm going to state the law, sine law, and I am going to write it out using the correct letters and values from the lesson, from the triangle that we were just working on. So not a generic ABC, but the letters that we were given. Now, it so happens we were given ABC this time, but that won't be the case for all of our triangles. So we could do the sine of C over C equals the sine of B over B. And as we substitute in, let me scooch that up just a little bit. And as we sub it in, we have the sine of 35 degrees over 30 equals the sine of 62 degrees over side little b, and that's the one that we're looking for right there. So this is what we're after for this question. Hopefully that model worked. I'll do one more though for sure, but angle ABC, we're trying to find side little b. Write down the three things that you've been given, so go reference the triangles on the next page. And then looking at that triangle and the piece of information you've been asked to find, figure out which of the tools we should use. And again, they're all listed up here. Sine law, cosine law, that's primary trig ratios, sum of interior angles, Pythagorean theorem, or insufficient evidence. If there isn't enough info there to get done what needs to be done, that's also a possibility. So hopefully that helps. We're going to work through this whole thing. That's actually pretty much the entirety of what we're going to do today. So let's go look at triangle PQR. We're looking for side, so that's PQR we're looking for. We have side little p that we're trying to find, so let's jump down and have a gander at that. There's PQR. Okay, so the one we want to find here is side little p. So what have we been given in this question? Well, we've been given a few things. We've got angle Q is going to be equal to 90 degrees. Let's get that in up there. Angle Q. And that will be equal to 90 degrees. That works. And then I remember we had two sides down there, so let's get a look at what those sides were. So this would be side little r, and this would be side little q. So we have side little q at 124, side little q at 124, and side little r at 74, I think. Where are you? Yeah, 74, awesome. So what is the best method here for us to use to find to find side little p? Now, again, to model this, we're dealing with a right angle triangle here. So that we have a right angle triangle means that we can use primary trig ratios and Pythagorean theorem. So in a question like this, we've been given two sides. The Pythagorean theorem kind of makes the most sense. So I would recommend the Pythagorean theorem for this case. So let's write that down. Heading all the way back up there. So Pythagorean theorem. That's a long one. Whoop. Pythagorean theorem. So normally, let's see, what do we got? So it's PQR, so normally that would be our hypotenuse was Q, so that would be Q squared equals R squared plus P squared. And specifically, substituting in the values that we know, that would be 124, what? That's not a number, 124 squared equals 74 squared plus P squared. And that's how we would go about solving it. So there is a second example. So if you're feeling good about this, by all means, you don't have to watch the second part of this lesson. You can just move forward from here and evaluate the triangles. I am going to talk through the next ones. I'm going to do it a little more quickly. But by all means, go and write down the information that we've been given. I'll certainly have that already prepped in there for the next lesson. And yeah, we'll see you back in here for part 2.